Ever wondered why ice doesn't instantly turn into water the moment it's exposed to heat, or why water doesn't immediately break into a steamy dance when it hits boiling point? Well, the answer to that lies in a fascinating concept called latent heat. Latent heat, in the simplest of terms, is the energy required to change the state of a substance without changing its temperature. It's like the hidden heat, the secret agent of the thermal world, working behind the scenes to make sure things change smoothly. The term latent comes from the Latin word latens, meaning hidden, since this heat, though it doesn't change the temperature, is very much present and plays a crucial role in the state change. The concept of latent heat can be split into two main types: latent heat of fusion and latent heat of vaporization. The latent heat of fusion is the heat absorbed or released by a substance during a phase change from solid to liquid, or vice versa, at a constant temperature and pressure. It's the reason why the ice in your drink doesn't just instantly melt away. On the other hand, the latent heat of vaporization is the heat that a substance absorbs or releases when it changes from a liquid to a gas, or vice versa. It's why boiling water doesn't instantly turn into steam. Now you might be wondering, how is this latent heat calculated? Well, it's not as tricky as you might think. The amount of latent heat is determined by the mass of the substance and a special characteristic of the substance known as the latent heat capacity. You simply multiply the mass of your substance by the latent heat capacity to find out how much latent heat is involved in the phase change. As an example, consider a cube of ice melting. The latent heat of fusion for water is approximately 80 calories per gram. So, if you have a 100-gram cube of ice, it would need about 8,000 calories to completely turn into water, even though its temperature remains at 0 degrees Celsius the entire time. In real life, the concept of latent heat is at work all around us. It's involved in everything from the workings of your refrigerator to the weather patterns you see on the news. The understanding of latent heat is also crucial in many industrial processes, such as distillation and refrigeration. So to wrap it up, latent heat is the hidden energy that a substance absorbs or releases during a phase change, without any change in temperature. It's split into two types: the latent heat of fusion and the latent heat of vaporization. The calculation of latent heat involves the mass of the substance and its latent heat capacity. And finally, this concept plays a vital role in many aspects of our daily lives, from household appliances to weather systems. Isn't it fascinating how something so hidden can have such a visible impact on our world? That's the power of latent heat, the secret agent of the thermal world, for you.